To understand graphing in 3 dimensions, you need to understand how to draw a rectangular prism. The first thing I want you to do is practice drawing a rectangular prism. Understand that these shapes repeat themselves. So if this is the front of my rectangular prism, the back will look exactly the same. So your first step should look just like this. Then whatever's on the right of the prism will also be on the left. So this shape right here will be repeated on the left. Now, to make this easier to read, what we do is we dash the lines that we want to be behind. And here you have a not very pretty rectangular prism. The thing I want you to notice is that the sides duplicate themselves. The bottom of the prism is at the top also. The left side is also on the right side, and the front is also on the back. When we draw points in 3 dimensions, I want you to draw the prism where the point is located. You'll have a prism somewhere on your 3D graph, and on that prism in one of the corners, it could be any one of the corners, will be a point that you're actually graphing. And this gives you a much better understanding of what 3D space looks like. When you're graphing in 3 dimensions, you need to imagine the corner of a room or the corner of a box. Look at the corner of your room. The z-axis runs vertically up and down where the two walls meet. The x-axis runs along the floor and one wall. And the y-axis runs along the floor and the back wall. We have an x, a y, and a z-axis. And just like on the coordinate plane, we have negative values. The x negatives are back here. The dashed line means it's behind. The negative values of y are on the left here. And again, the dashed line means it's behind. And the z-axis continues below. Those are the negative values. It's underneath. I put some tick marks on my axes. And now I'm going to graph the point. X is 3, Y is 3, and Z is 3. X, Y, Z, an ordered triple. And this will look a little bit different. Remember what I said. You're actually graphing a prism, and the point will be on one corner of the prism. You must graph it this way so that I know you understand how this works. So X is 3. I'm going to go out on the X-axis and count 1, 2, 3. Now I'm sitting right here. Y is 3. Now I'm going out parallel. This is the bottom of the prism. I'm going out parallel to 3. Now it looks like I haven't gone to 3, but the thing you have to understand is where Y is 3, I'm going parallel to the x-axis to actually go a distance of 3. So far what I've done is X is 3 and Y is 3, and I'm right here in this corner. Now Z is 3. To understand where Z is 3, I'm going to draw up parallel to the Z-axis, and then I'm going to come back parallel to the X-axis. And I'm going to go parallel to the Y-axis. And come up parallel to the Z-axis. Now, I'll draw in the rest of the parallels, out parallel to the y-axis and parallel to the x-axis and then parallel to the z-axis. So now follow the point, go in order. X is 3, I get to right there. Y is 3, I get to right there. And Z is 3, I go up and my point is actually sitting right here. Notice that Z is 3, but when you look at 3 on the Z-axis, it looks like it's underneath that. That's because the top of this box is parallel to the XY plane. This is the correct location of the point. Here's another example. You can just sketch it with a ruler. You do not have to have the fancy digital graph paper. But if you want the digital graph paper and you have access to a printer, you can go to my website and click on resources and you will find some 3D graph paper you can print out. It's just fine to draw it like the previous example. That's all I'm expecting. But again, please use a ruler and be as neat as you can. Let's take a look at this one. -3 for x, 6 for y, and 5 for z. So I'm going to go out to -3. I'm right here. And 6, I'm going to count 6 on the y-axis. 1, 2, 3, 4, 5, 6. And I'll come out parallel and parallel. So I'm parallel to the y-axis here. And the other line is parallel to the x-axis. Z is 5. 1, 2, 3, 4, 5. So I'm going to come out parallel to the y-axis. And I'll go parallel up to the z-axis. This line here will be repeated above. So I'm going to duplicate that line right there. And I'm trying to make it the same length, but I'm going to go up parallel. It's fairly close. And this line here will get repeated in the back. The bottom of the box and the top of the box is supposed to be duplicated. Well, it's not going to be perfect. It's difficult to be perfect, but that's fairly close. So we're going to follow in order. We're going to go -3 for x, 6 for y, and then up 5. And notice that it's in the back corner this time. Go in order. -3, 6, and 5. And there's our point. Now label it clearly when you draw this on your own. Make your point very obvious, but you should have a prism on every single point you graph. There's only 4 of them, and these are the harder ones to do. The planes are much easier. A plane turns out to be a lot easier to graph than a point. That's because we only draw a little cross section of the plane. And the way we do that is with intercepts. Now, remember what you did with intercepts in 2 dimensions. If you were looking for the x-intercept, y was 0. If you're looking for the y-intercept, x was 0. You do exactly the same thing here, except if you're looking for the x-intercept, y and z are both 0. If you're looking for the y-intercept, x and z are 0. If you're looking for the z-intercept, then x is 0 and y is 0. And plugging in zeros makes this easy to do. When you plug in 0 for y and z, you're left with the equation 6x equals 12, which means x would be 2. If you plug in x is 0 and z is 0, plug in x is 0, the 6x is gone. Plugging in z is 0, the 2z is gone. You get 3y equals 12. 3y equals 12 means y would be 4. 3 times 4 is 12. And for the last one, you plug in x and y is 0, make these two 0, and you're left with 2z equals 12, which means z is 6. So you plot those points. They're on the axes, 2, 0, 0. X is 2, y and z are both zeros. Y is 4, x and z are both zeros. 1, 2, 3, 4. There it is. And z is 6, and x and y are both zeros. These are intercepts. They're on the axes. That would be right there. We connect those points. That triangle represents an infinite flat surface. You have to imagine it going on forever. But that triangle is where the plane intersects the octant. That's one of the 8 areas that you could be in. It represents where the plane passes through the axes. And so you have to imagine that surface continuing on forever in all directions. One more quick example, and then we'll take a look at what this would look like on a computer. So to graph this plane, I'm going to look for the x-intercept, which means I'll be on the x-axis, and that's where y and z are 0. To be on the y-axis, both x and z will need to be 0. To be on the z-axis, x and y will have to be 0. So plug in zeros for y and z. That's this one and this one. And you get 6x equals 24, and x would be 4. Plug in zeros for x and z, for that one, and you get negative 3y equals 24. Divide by negative 3, and y is negative 8. Plug in x and y is 0, and the x term and y term drop out. Negative 4z is 24, and z would be negative 6. Plot these values. They're all intercepts. X is 4. Y is negative 8. I had to continue the negatives a bit. Negative 8 would be right about there. And z is negative 6. 1, 2, 3, 4, 5, 6 is down there. Now this is going to look weird. I'm just warning you. When you look at that, it's hard to tell what it looks like, but understand it's a triangle exactly like the last one. The reason it looks that way is we're looking down on it and we can't see the whole thing very well. If we were underneath, we would see a clear triangle just like the last question. So a couple of these can end up being kind of strange, I'm just telling you, and that's because we're drawing 3 dimensions on a 2-dimensional surface. It's the best we can do. Now let's take a look at what some of these would look like on the computer. Here are the 2 points that we graphed, and I did them on the computer. The computer didn't allow me to extend the axes. 3, 3, 3, you can kind of see it. Remember, this is sitting on a prism, a rectangular prism. And the other one, again, is sitting on a prism, but it's kind of hard for us to tell where it is because our axes aren't big enough. Still interesting to look at. Here are the 2 planes. We can see the x and the y-axis is the horizontal plane, and the z-axis going up. These are the 2 that we graphed, represented on a computer again.